Hello everyone. Let's start today with a new problem called merge sorted array. So it's a easy problem on LeetCode, but yeah, it's not that easy. Uh, let's think of it this way. So we have an array with 1, 2, 3, and 0, 0, 0 at the end, and another array with 2, 5, and 6 elements. At the end of the array, they want something like this, where the last three elements are replaced by these three elements, but like not directly, but in a sorted way. So I think you can also consider this as 1, 2, 3, 2, 5, 6, and sort it out. That's an easy way to do it. But like they want the they want it to go in a algorithmic way where they have two arrays and they sort it out. So yeah, that's the question. So how do you think our approach should be? So yeah, I think if you take an array of like 1, 2, 3, 0, 0, 0, and 2, 5, 6. What's the length of this one? It's 6, right? This one is 3. So, and they also give you the length of the array, individual array. So it's like 3 and 3, right? So the total length is the arguments for both the arguments for the problem would be nums of 1, which is the first array, nums of 2, which is the second array, and also uh, length m, which is the length of the first array, and length n, which is the length of the second array. So the first array's length is 3, right? So m would be 3, not the entire array, because like that you can get the length from nums 1 dot length or size. But yeah, but they just give the this part of the array so that you can use that for uh, you should get this number so that you know what where the zero start and where you need to replace them. So yeah, how do you think we should approach this? uh, I think the first thing would be having like a what do you think the approach should be? So in general, any merge sorted array, any merge sort algorithm goes like this, where like they find two last elements, like if there's 3 and 6, um, they take those two last elements, compare between them, like either greater than, less than, or equal to, and like um, whatever comparison result you get, like take this as x and y. Whatever comparison you get at the end of the result, you use that to place the element where you want to position. So if you think, in this case, take the greatest element between those two elements and use that to fulfill the array at the right position. So this is the greatest number, right? So it should be at the last, and similarly next greatest. So then you compare 3 and 5. What's the greater one? 5. So then you compare 3 and 5. 3 is better, so you get 3, then you have 2, and then you get um the next element in the next array, which is 2. Because both are equal, you choose one, and then you choose the other one. Once you choose the other one, you replace it, and finally you get number, and you replace that, and that's your entire answer for the array. So yeah, I think I, once that you because you understood the algorithm, yeah. Um, let's see how what variables we need. We definitely need a last variable which tracks the end of the array, which is like m plus n minus 1, because like you need minus 1 because um, m plus n are like the array lengths, right? So if it's 3, it's 3 plus 3, which is equal to 6. But like arrays only have like a length of 0 1 to 5, right? If array is of length 6, it has 0 indexes of 1 2 3 4 and 5, right? So you need a last variable where it says m plus n minus 1, which actually tracks it. Also you need a left variable, um, like I don't know, L, where L is equal to initially M, and you keep shifting the L variable. Also a right, uh, yeah, R, which is initially equals to N. And now um, you decrement each time you decrement a number each time you see something. So like while M is greater than 0 and sorry, L is greater than 0 and M is R is greater than 0. Sorry. That will be your first condition, right? If your nums1, I'll just do n1 for after this thing, but like nums1 of your length, but like because it's this thing, it should be n1. L is greater than nums2 of R. You're taking the last, so like imagine there's like 1 2 3 0 0 0, right? And 2 5 6 0, only this array. So you're taking R as this element, L is this element 3, and you're comparing both of them. And once you compare the result, because uh, R is greater, so whatever is greater, so like then nums1 of last, which we kept track of, which is this element by the way, is equals to nums of L, and you decrement last, which is equals to minus equals to 1, and you also decrement L, right? L equals to L minus 1. uh, yeah, any questions? No, right? Let's go to the else condition, which is because yeah, nums1 of last is now equals to nums 1 here, right? Because like nums2 is greater nums2 of R, and you similarly do last equals to last minus 1, so minus equals to 1, sorry, minus equal to 1, and right equals to right minus 1, right? You can, yeah. And then what? And then um, finally, if like, so if it again, I'm gonna write the code in a separate window, but like to explain it better, I need this graph. So 1 0 0 0, right? And 2 5 and 6. So if you replace so we replace whatever in or whatever is in the first array will remain in the first array. But like once we run out of m's, like imagine if there's like one two uh if there was more n's than m's, like if there is 2 5 6 and like 1 here, and like there's only 3 elements here, like there should be a 0 here, right? So once you replace everything at the right place, then you may be left, so like because m and n both should be greater than 0, if one of them run out, you take the remaining elements of the last of the second array and replace it in the first array. So something like it goes like this: while n is greater than 0, because like we are or like right is greater than 0, nums of last is equal to nums2 of r minus 1, or like r equals to r minus 1, right? Or like actually r we already nums of r, that sounds good. And we decrement r equals to r minus 1, and we also have to decrement last as usual, last equals to last minus 1. This will solve the entire problem of merge sorted array. Finally we'll have an array that fixes most of the cases. Yeah, uh, it may not seem as easy as it should be, but like yeah, it's not. Yeah, let's just see the code once more. So yeah, uh, let me just explain the code once more. So initially we will have a basic class solution uh, with the method merge with nums1 int array as one input, and length of nums1, not the entire length but like the length where ints are contained or like numbers are contained as m, and nums2 as the other array, and length of the complete length actually for the nums2. It's a little, if you see the earlier video, earlier part of the video, you'll understand better. But yeah, so you'll initially declare your last variable, which is lengths of these two, minus one because like if there is array indexes range from 0 to n minus 1, not n, so that's why you do a minus 1. And similarly same for the left and right. Left is the left array's index, right is the right array's index, not the complete array's index. You get it, right? So now we see if left is greater than or equal to 0. It's not double equal to, but yeah. So it's left greater than equal to 0 and right greater than or equal to 0. Then you compare nums of left with nums of right. If left is greater, that means left goes at the end, right is greater, right goes at the end, right? So nums1 of last, which is the last index, uh, first takes in the left thing, and left goes minus 1. And similarly if right is greater, this means else condition is when right is greater, right? So nums1 of last will become right, and right will become right minus 1, and in both cases we anyways have to do last minus 1. So instead of doing it in the if condition and else condition, we do it outside the condition, so that it does it for both the conditions. And finally we'll have while right is greater than 0, because like you have to empty out the second array. This will empty out the second array, which becomes nums1 of last equals to nums2 of right. And then you have to um, reduce the last and reduce the right. This will take it up. Yeah, that's it. I hope you got the point. Any questions, please post in the comments. Thank you.